Morning. So Jesse, tell me about that giant guitar you're holding. Is that a skill you have?
Yeah, that's an upright bass,
Yeah.
and I do play it. My favorite is jazz music.
That's super cool. And you're in
Yeah.
some kind of a awesome attic up there.
That's over at the Applegate Lounge. I took that as my scene picture.
Yeah. Okay.
Yeah. Yeah.
I've been out there. That looks like it would be out there.
Yeah.
That's outstanding. I love that. Good job. So that's not a giant guitar. Okay.
No.
I'm just kidding. That's really neat. I love that. You know, one of my favorite things about teaching this class,
What's that?
it's when I get on Zoom and I see myself for the first time today. And I go, look at that, man. My hair is like sticking straight up right there.
That's fantastic.
That's not my favorite. Let's see. I have graded all of your quizzes, sort of. There were 3 of you, I can't remember which 3, whose quizzes were sort of big enough that when I downloaded them and opened them, there was nothing on them because it was like such a big file it couldn't handle it. So I got to go back and grade those. I'll just have to email you. I'm still kind of experimenting with how to do that. This time I figured out a way that's kind of a faster. I was linking them back in my open math for you, but this time I realized it was a little bit faster to just sort of send it directly to your email. So I put points in my open math, but I emailed your quiz back to you. And that's important as far as today's discussion, because if there's anything wrong in that quiz, you want to know that for the test, because these are very test-like questions that are on that quiz. And the main thing I would be concerned about is not, accidental errors with respect to, oops, I took the integral wrong or something. Like those things are going to happen as long as you look at your work and go, oh yeah, that was a mistake. But I'm concerned about the conceptual things, because I will ask on the test, find this volume using cylindrical shells as opposed to washers. And again, I'm actually doing that not to limit you, but actually to help you not have to wonder, because sometimes one's easier than the other. And leaving a class like this, you'd want to be able to do both of those methods. So let's see. I'm just going to stare at the test really quick just to see if what I said is true. Typically too, kind of like I did on the quiz, on the test, I'll say something like find the exact area. If I say that, then you won't be able to cheat. Does that make sense? Because all of these areas and volumes end up with pi in them. Since you're spinning them around something, you're always dealing with circles, and circles have pi in them. And so you're basically, what I'm saying is, hey, hint, you're going to be able to take this integral yourself. And I'm going to make that integral, it'll always be easy, just like the quiz was. There weren't any hard integrals on the test. All of them were just power rule related problems. So, and I'm going to give you figures, just like, well, let's take a look now at the review. Oh, I got to go kayaking yesterday. It was so great. I haven't done that forever. It was cold though.
Where'd you kayak?
I managed to get my son-in-law into it. We just did Gold Hill. We did the Nugget stretch. It's kind of high water. It was he ran an entire nugget upside down. It's like 50 yards long, and he flipped at the top and ran the whole thing upside down. He was freezing when he came rolled up. It was awesome.
Sounds scary.
That's what I was gonna say.
Yeah, I was impressed that he didn't panic, because being upside down with your head down, going through rocks in the winter, that takes some coolness. I was impressed. So yesterday I showed you a bunch of applications, and really it all came down to, because integration is area under a curve, and area under a curve is always the height unit times the kind of the x unit. You're always multiplying something. An integral is an area, therefore you're always multiplying something. So did you notice that happened yesterday? The last example I gave, for instance, had to do with the torque, which was force times distance. It's like two things multiplied. And so that's where all the applications kind of come from. You know, these problems are nicer because you're actually staring at a graph. And so, you know, finding the area under a curve is a little more kind of obvious that you're multiplying something. So notice this one very naturally. If you say, for instance, hey, look, sales per month, and then times the other unit, months. Oh, look, those are going to cancel. So if I find the area into this curve, I'm going to get sales. So, you know, might throw in an application of that nature where area under the curve, you know, makes a difference. Anyway, I think you probably feel relatively good about those, but these, you know, these questions are the ones I'm concerned about. And this is what the test questions are going to look like, in the sense that not only going to give you a graph just to save you a little bit of time from doing it yourself, but I'm even going to tell you the intersection points, which of course you have to know. So we're talking about, you know, even without reading this question, I hope you can look at this and say, oh, you know, look, there's a shape. And there's just leaving calculus, and you know, this is a little intimidating for a test, which is why I think a review is so important. You should say, man, there's just all kinds of cool stuff you can do with that area right there. You could spin it around the x-axis, and in doing so, you could say, well, what do I have there? Well, I got this, you know, cool kind of donut-ish shape. Well, what can you know about it? You could find its surface area or its volume. And then I could also spin it around the y-axis and do exactly the same thing. And so the fact that you're creating these shapes rotationally, they're rotationally symmetrical, if you will. Anything that you would look at kind of in a room. I'm looking across at this cool little lamp that my nut friend gave to me, but it's got this bushing thing, it's called, which is takes a pipe from one size down to another size. So there's like a small pipe coming out of this size and a big size, and so it's like a plumbing part. So I'm looking at that fixture, that picture right there, and I'm thinking, oh, look, you know, that thing has a rotational symmetry. And so again, I want this to ruin your life. Like, look around you in the world. You're going to see a ton of things that kind of have that round, like it was made by rotating something. And I hope this affects your thinking. And so, you know, any physical object, for a person to be interested in its surface area or its volume. Surface area because you're going to paint or coat it with something. Volume because you got to, you know, make it out of steel or whatever. So how much steel is that going to take? Or as I said yesterday, even better, could you get density involved and then actually figure out what it's going to weigh, because it was made out of brass. What I'm looking at over there is made out of galvanized metal. And so, you know, could I look up online I'm not going to ask you this on a test, but after finding the volume, could you then say, now it's made out of brass, and then based on the brass's density, say this is about how much that part's going to weigh? Again, that just to me would feel really satisfying to, you know, then make the part and then go put it on a scale and go, look at that, you know, man, that's cool. I predicted it. I knew before I built it. I could tell somebody before that, you know, I made it. This is how much it's going to weigh. This is how much it's going to cost to ship. And so
My
That's the
grandfather
big
makes
picture of this. So yeah, go ahead.
my grandfather makes like wood turned lamps and things on a lathe.
Yeah.
And this class always makes me think of those when we're taking the areas and the surface areas.
Yeah, and to me, I mean, that's what this last project, and by the way, we have some time today. You're more than welcome to ask me questions about your project, or, just simply if you got it right or not. But it'd be even funner, if you will, or even more natural if you could walk up to something like those lamps your grandfather's making with a tape measure or a caliper. Caliper is like a tool that'll squeeze down on something and tell you how tall it is. It's actually hard to measure something round with a tape measure. And take your own measurements. Does that make sense? And wouldn't it be cool to take your own measurements of some cool shape and then figure the equations out for it? I erased it, but the shape that I just drew has like a part of a circle in it. So you'd have to develop those equations yourself, measure the radius yourself. And so the project you're working on is related to that. It's as close to that as you can get by just giving somebody a kind of a piece of paper problem. So notice I asked you, because I think this will really help you put your mind around all of this. I asked you kind of everything. I just took that shape right there and said, let's find everything. So from earlier in this class, can you just find that area? It's two-dimensional. Can you find that area? Or B, can you find the volume rotated around the x-axis? Notice in this problem, I didn't say using shells or washers or whatever. I just said, use whatever the heck you want. Or find the volume rotated around the y-axis, or find, oh, there's something else I forgot. Find the arc length of the parabola from 1 to 6. What's the length of that arc that cruises around right there? So it's just amazing all the stuff we can kind of do now. And then find the surface area of it rotated around a particular axis. I mean, that's a great question. If you can slowly today work your way through a problem like that, and you're probably going to miss something, but the question is it small? Can you draw pictures on it? I'm really hoping these figures, you can kind of go slow. The biggest thing I saw wrong on the test, for instance, or on the quiz I just graded was, get out of there, was, for instance, let's say you're going to spin this thing around the y-axis, and people that were using shells, it's very important you understand, what is it you're spinning? Well, you're spinning that. And so how tall is that? Well, it's sort of, there's y blue, there's y red. Of course, I could say parabola and line. And so I'd be subtracting those two. That's how tall that would be. It's like the y value of the parabola minus the y value of the line. That's how tall that shape is right there. Like, you got to see that. You got to draw that in my opinion, in order to then say, okay, I'm going to use shells and I'm going to send that around this axis right here. So I know how tall it is. Oh, look at the picture. There's its radius. It's an x value. So its radius is an x. Its height is based on y. And then notice its little tiny thickness right there. Well, again, that's horizontal. So that'd be a little bit of x. Like, being able to visualize that. And now I know what the formula for that volume would be, that shell, because it'd be 2 times pi times its radius times its height. I'll just write y minus y. I guess I could do both. Times its thickness. So that's the formulation of the integral. So now that I wrote that, I'm saying, oh, look, I'm stuck with x's. Oh, look, there's an x. Awesome. I don't have to mess with it. Oh, not good. Y's. Have to change those. Well, right up here, I have the conversion between y to x. And so I'm just going to replace that y of parabola with this parabola's y value. I'm going to replace the y of the line with that line's y value. And now I have this big, ugly equation. And maybe I can take its integral by hand. In this case, I can take it by hand pretty easily because I'm just subtracting a parabola and a line. And so I just get this polynomial equation. And then if I distribute x inside, that squared equation will go to a cubed equation. So I could get this exactly right if I had some reason to. So that's the logic I want you to walk away with. But again, it's asking a lot because you have the shell method and the washer method, and sometimes there's a hole that's missing. And I saw in the quiz I graded, some people kind of forget, oh, there's a hole there. I gotta, subtract this out. And since I'm working with x, then I say, oh, look, this goes from x is 6.5 to x is 1. So you really can just invent this from nothing with some practice. Anyway, that's all I really want to do is just, so there's a shape bounded by a parabola and a line. There's an area bounded by a parabola and a parabola. There's an area bound by, what is that? Oh, that's an interesting equation. 8 over x. It's a rational curve. It's not a parabola or anything like that. And so there's a sort of a triangular shape again, based on your project. This is really similar to that. Or down here, look, there's a sine wave and a line. Sine wave bounded by a line. So I'm getting these areas, and then I can just spin around stuff and find all their surface areas and volumes. And so this is a really good practice. I mean, if you can, I don't want to say march through this, but if you can get through this and make sense of it, you're going to just tear this test up. It's going to be beautiful. So my advice would be pick these 4 questions, 3, 4, 5, 6, and just pick stuff you won't have time during class, but I want you to pick the stuff that feels the hardest to you. And I guess I'd encourage you, maybe in the interest of time, don't even solve them. Just see if you can set the things up. If you can set it up like this, again, the integral taking part of it is not really the hard part. It'll be easy on the test. And like I said, sometimes I'll even just say use your calculator to evaluate it. But I would guess in the class period, I think you could set up, you might be able to actually set up all of the integrals that I'm asking here. But notice it looks like only 4 problems, but every one of them has like A, B, C, D. This is like 20 questions. There's no way the test is going to be this large. I'd only need to give you one question like this, and that would represent the whole test, right? Like question 5 right here, A, B, C, D. That's the whole thing. That's everything we've studied this in chapter 6 in one question. So let's let this devolve into you messing around with this. Feel free to just chime in and say, here's my setup for question 5B. Is that right? That kind of a thing. And I can check it. You also have access to the answers to this online too. So you're obviously on a computer, so pull it up and check it yourself. The only concern I would have is the surface area questions. There's more than one way to conceptualize those. So I will have picked one way, but all I mean by that is, remember how we said that for the surface area, you have 1 plus either dy dx squared, and then that would be dx, or 1 plus dx dy squared, and then that would be dy. So in other words, this one you're working with x's, this one you're working with y's. So then that's going to change what's kind of sitting out front. So there's 2 ways to do those, and I probably only picked one of them in terms of my answer. So don't just punt and like try to do what I did. Ask me and say, what I'd really rather you do is just say, here's what I'm thinking. What's wrong with that thinking? Let's fix your thinking today, not just try to copy, whatever I did. So turn loose and practice away.
So Doug, I kind of had some preloaded questions for today. Do you mind if I just fire one off?
Love it. Good for you.
So, for example, it was during the take-home quiz. I was kind of doing the take-home quiz as we went along, 6.4, 6.5, 6.6. And so I went back to review them, and I was watching Khan Academy. And the way they did it was if a triangle or if something was away from the y-axis or away from the x-axis, instead of just putting x or y after 2 pi, they would put 2 pi x minus 5 or, you know, y minus whatever, or y plus or something, to show that it was across from the y or x axis. And that wasn't what I put when we went over it in class, so I kind of kept it how it was, but it really kind of confused me and, you know, made me think differently.
So you felt like you were getting it until you looked at that Khan Academy video?
I felt like I was getting it, and then I looked at that Khan Academy video and what they did made sense to me. And so now I'm just confused on if it's like away from the x or y axis, why are we still only putting x or y?
Well, the problem is it depends on whether you're doing shells or washers. That's the problem. I don't know if that makes sense, but let's say I had this interesting shape right here. And actually, maybe you tell me, what should we do with that? Should we spin it around X? Should we spin it around Y? And should we find volume? Like,
I would spin it around X. It seems pretty easy to do.
Okay. So you're saying, okay, let's send this guy around here. And what are we finding? Volume or surface area?
Volume.
Got it. And this is the problem, because the question is, do you think of this as shells or do you think of this as washers? And so let's do both. So I'm gonna let's do washers and shells. So again, for me, I'm looking at pictures here. So I'm thinking, okay, if this is going around X, then I'm going to need to make a slice right here. And then I'm going to send that slice kind of around the x-axis. And so what I'm really getting is something that kind of looks like that. Wow, drawn like a first grader. That's the shape that I'm really getting right there. So I'm thinking, okay, well, I'm going to have to take kind of the outer minus the inner. And that's a cylinder. So the cylinder's volume is pi times radius squared times height. So I'm thinking that's the radius of the outer function, which would be a y value in this case. I'm just drawing that in. And this would be the y value of the inner function. And the thickness of this is a little bit of x. So then my setup would be pi times radius squared times height. So there's the outer minus pi times radius squared dx for inner. That's my basic setup. And then again, as we're always going to see, I end up with a mixture of x's and y's. So I like to think of it as, well, dx, it's easier to be stuck with dx. So I'm just going to replace these two statements with whatever those equations are. Notice in this case, notice that y value might be a constant. So say that's a 4. Okay, great. That's just a 4 then. It's a constant. Awesome. Whereas this up here might be some equation like y equals 1/2 x plus 2. Okay, fine. I'll replace that with 1/2 x plus 2, and it's still squared. So now everything is in x's, and then it tells me, oh, okay, well, now that I'm in x's, where does this thing live with respect to x's? And then I look here and say, well, it lives from there to there. So if that was like from 7 to 12, and I'd say, okay, great, that's from 7 to 12. I mean, that's the way I formulate these things. All I have to really know is the volume of a cylinder is pi r squared h, and you have that it's probably stuck in your head, but you're more than welcome to look at that geometry sheet. Do you track with that, Connor? Do you find yourself going, okay, I get
No,
that.
yeah, that makes perfect sense. And I actually find myself doing the washer method when I should be doing the shell method.
Yeah, now let's take a look at the shell method. The shell method is where you take a slice that's in this direction and you send it around. So that thing's going around in this direction. And again, I think that's fairly challenging to try to visualize that. So let's see, what's its kind of height right here? Well, isn't that height? And this is kind of not a very good example for this problem. Now I suddenly realize like shells isn't going to work very good right here, because would you agree while this thing is down here, the height just stays the same all the time? If it was 12 and 7, then that height is 5 the whole time, right? But then when it gets up here, then it's actually going to start getting smaller. So this is actually trickier to do with shells. Wouldn't work very good. Just to make it a little simpler, let's just make it a triangle. The problem is we got to make sure the height is always basically in that case, washers would be the better method. So like if I actually gave that question a test, I'd probably say use washers to calculate this, just because shells is more of a pain. So if I make this a triangle, it'll make a little more sense. So
because the height should be y0 minus that constant on the right, right?
yeah, see, the problem is, and this is why I think I have to draw this in, is how tall is that? Well, I got a x value there, which in our case went out to 12. And notice that just stays 12 the whole time. So I've got an x out there, but then I've also got an x right here. And it's the difference of those two. So x outer, x inner. So then that height right there would equal x outer minus x inner. So those are x values. And then notice the radius of this is a y value. And because it's vertical, the thickness of this is a y value. So then if I took that shell, that piece of paper that's kind of spun around, being spun around in this fashion right here, that's my shell, and I open it up, then I say, oh, okay, cool. That height right there is the circumference of the circle. And this was my x minus my x, and then I have a thickness, and I just need to multiply those because that's a box, effectively a prism. So I say, okay, well, the circumference would be 2 times pi times radius, which is that y value right there, times this height times the thickness. And so now I need to add all those up. My thinking is, as I've said before, oh, I'm stuck with y. Yay, there's already a y right there. Awesome. Bummer, those aren't y's. Okay, well, I'll have to switch them out for whatever y values they are. Notice that in the case of the outer, that's 12. So, okay, good. That's not x's anymore. That's just 12. If this equation right here was y equals 1/2 x, let's just leave it the way it was before. 1/2 x plus 2, that's kind of a bummer because I need to replace that with y's. And so I'm gonna have to resolve that. I'll have to subtract 2 from both sides. multiply both sides by 2. So there's x. So then I can replace that with 2y minus 4. Now it's all y's. And then again, I think, oh, y's, cool. Well, where does this thing live? What y values does this live between? Well, it lives between that y value and that y value. And so if that was from 8 to 13, then I'd say, okay, cool, 13 to 8. I've had a lot of practice with this, and I know the geometry formulas. I see this stuff, you know, in a sense better than you guys would. So I know I make it look easier than it is, but you really can draw pictures of this. You don't need any formulas except for the geometry formulas.
I feel like the formulas are kind of what's trying to help me, because if I were to put, so the whole equation is 2 pi xh, and the height of the shell is in there, and you put the height as 12 minus 1/2 x plus 2, when I would have put the height as 1/2 x plus 2 minus whatever that red, you know, that red line is on the right, the vertical. That's what I would have put the height as, whatever that is.
12. So you're saying you would have had these two backwards?
Yeah, it's just how I would have thought in my head that it's the slanted line minus the constant vertical line.
Yeah, and that's why you need to draw the picture, because in your case, if you did that backwards, you'd actually have a negative height. And you wouldn't notice that until you got to the end, and then suddenly you'd have an answer like negative 27 or whatever.
And that happened to me a lot on the quiz.
That doesn't make it wrong. What I'd love to see on the test is, you know, oops, I subtracted backwards, and then you just tell me the positive answer. I didn't mark that wrong on people's quizzes. I pointed it out. I put arrows and said this should have been here and that should have been there. So, you know, when I draw this picture out here with this height that's clearly longer than this height, if you subtract big minus small, you're going to get a positive height. If you subtract small, and that's why I've got to draw a picture, because I'm not going to see that. It's a question of what's on top of what. And again, sideways I think is harder because it's not so much what's on top. That's why I didn't say, you know, x top minus x bottom, because it's not top bottom, which is exactly what's confusing you. It's really right left. Does that make sense? It's a mistake you're not going to make up here, because here it's sort of obvious that this one is, you know, way taller. So you're taking that equation up there and subtracting this shorter one from it. It's easier not to make that mistake. But if you draw a picture of it and it makes sense, then
I see. Okay.
that takes practice. Like I say, you're watching me do this once and a little bit of practice. You're not going to be a master of this in one pass. But again, that's why I'm giving you a lot more practice. I think the projects that I've given you during this and the take-home quiz have given you some, you know, really good pictures, and you need a bunch of that to kind of go, okay, I think I see this now finally. Anybody else? Keep going. If you have anything you want to say, just chime in.
I have a question about setting up number 2 on the review.
Go for it.
So the pi t times 5, when you take the integral of what's inside that, or how does that work again?
Yeah.
I used myself.
Yeah, so you have to see that as the integral of sine of junk, because it's not just sine of x. And of course, with pi in there, it's uglier. But if it had been something, just to keep it simple for a second, if this had just been the sine of, say, 4t, so that it looks a little more obviously just a number. You have to see pi over 5 as also just a number. It's ugly in every respect. It's a fraction instead of a whole number. It's got, pi instead of a number. Even if it had been 2/5 instead of pi fifths, it would have felt more natural. So you can do substitution for this and like say, well, I don't really know how to do that, but I know if I let x be 4t or u be 4t. But in the end, the integral of sine of junk is not cosine of junk, but negative cosine of junk, because the derivative of sine, so the integrals go in this direction, the derivative is going that direction. So the derivative of cosine is negative sine. So that's why there's got to be a negative sign there. But if you were taking the derivative of cosine of junk, you would say derivative of cosine of junk is sine of junk, but then it would be times the derivative of the junk, in other words, times 4. So that if I'm doing an integral, then it would be the opposite of that, divided by 4. So I'm dividing by the derivative of whatever's inside there, which is what, if you did substitution and were a little more, did it more slowly, that's what you would see happening. So in my case, it's the same thing. It's just I'm going to be not only getting the answer negative cosine of pi t over 5, but I'm also going to be dividing by pi over 5. Do you see that?
Yeah, I was in the derivative mindset, not the integral.
Yeah. Well, and of course, in a test environment, to kind of flub that up wouldn't be weird. Which is why, it's maybe better to slow down a little bit and actually use substitution just to kind of make sure.
I have a question about number 5. So I got 36 pi as the volume. And I'm not sure if that's the right answer.
For which one? C?
B.
That's one. That's double what it should be. Tell me what your setup is.
So I set it up as 2 pi times the integral of x times f of x minus 1. And that's where I went. That's what I started with.
Did I write down what you just said?
Yeah.
Got it. So the volume of the region rotated around the x-axis. And so you're thinking, I can tell from what you just told me, but are you using shells or are you using washers?
Shells.
Correct. Because notice there's 2 times pi times radius. So you're saying this is your slice. And if I send it around kind of in this direction, then the radius of that slice is x. So notice there's a 2 pi radius right there. So you got that right. And then this height would be x minus x, which could be why it's wrong. So x outer, x inner. Well, x outer would be, let's see. And by the way, the other thing you should sort of add here is the thickness of that is a little bit of y, because that tells me I really would like y values for that. I need y values for all of those things. Do you agree with that?
Yeah.
So where'd you get the 1? You said f of x minus 1.
I think I was
Oh,
using
yeah,
the
using this.
f of x value, yeah. And I was thinking that would be my height of the shape as I moved along the x-axis.
To see what you really did is you considered this to be your height. So you're kind of confusing shells and washers. That would be your height if you were sending it around this way using washers. But if you're using shells, your height is sideways. So that's what's wrong. You're kind of mixing those methods up, which again, I think would be normal for where you guys are. The question is, do you see that? So what I'm saying is that's not true. You suddenly went Y values there. That's not true. Oh, actually, I'm an idiot. Back here, that's not a Y value, or that's not an X value, is it? Isn't it a Y value? I called it X. It's not an X value, that's vertical. It's a Y value.
Okay.
So you mix that up too. You did say B, right? You're going around the X axis.
Yeah. So what would I use instead of that? What would I multiply my radius by?
So it should be 2 pi y, and then times x outer minus x inner, and then dy. And so now I think, oh yay, that's a y. That's actually good news. I don't have to mess with it. But now I've got to replace these two statements with y values. Does that make sense? I got to make y's out of those. Well, notice this distance right here is just 2. So that makes x gone. Now it's a 2. So it's a constant. So it's okay that it's, it's not an x anymore. I can't have any x's. Well, that's a 2. So I don't have to worry about that one now.
And that's a 2 from the y-axis, right?
Yeah, that's a 2 from this distance right here.
Okay, because there's also a 2 on the x-axis, so I want to make sure.
Yeah, well, it's that 2 right there. That's how long that is. That's how big x1 is. That's how big the radius of that is. And this is what's putting a hole in it. Because when I spin that around, there's going to be kind of like a hole drilled down the middle of it. And that 2 is giving us that hole. It's taking that away. And then the equation y equals 8x, well, I just have to resolve that. So if I multiply y, x over to the other side, and then divide by y, I get x is 8 over y. So then if I replace this with 8 over y, sweet, now it's all y's, or at least not x's. And then I realize, oh, okay, I got to know what y values I'm at. Well, there's the top at 4, and there's the bottom at 1. So this would be from 4 to 1. That would be shells. Again, on the test, I'm gonna solve that using shells and washers and kind of look at it. And I'm going to tell you both, because I want you sometimes I want to show on the test that you know both, that you can do shells and you can do washers. But I'm also going to pick problems where that, one of them makes more sense. So if we redid this with washers, it could be that that's the hard way. And I don't know about you, but I have a hard time with shells when it goes around the x-axis. I have to concentrate really hard, and then the reason for that is exactly from what you just saw. Cheyenne's comments were, it's harder to see stuff when it's kind of sideways. If it's going around the y-axis, I can see shells a little bit better there personally for some reason.
Yeah, I think I do kind of the same thing.
One thing I would say is, does it make sense every single problem? If you did a volume using shells around the x-axis, every problem is going to look the same. It's going to be 2 pi y times x outer minus x inner dy. Like that's what every one of them is going to look like. So what's it going to look like if you go around the y-axis? Well, now its radius is going to be x, not y, and its heights are going to be y's, not x's, and it's going to be dx. Like that's what every single problem is going to look like.
Hey, Doug, I think you have an error on your answer sheet.
That would not surprise me. What do you think it is?
So for problem number 3b, you take your integral, and when you square it out and expand it, you have 87x squared, and I have 75x squared.
I'm checking that right now, because that would be good to. So you agree with my setup that it's just maybe.
Yeah, I'm thinking maybe you just copied a number down wrong or something. Oh, wait, never mind. I had a mistake. I had a mistake in my arithmetic.
Yeah. And again, that's why I want your work to be clear, because so what? You made an algebra mistake. I'm going to try to make each question worth like, 6 or 7 points, so that if that's all your mistake is oops, I got in a hurry and multiplied it out, but all your calculus is right. And I can take 1 point off out of 6 or 7, and you still get an A on the question. So you're going to make a mistake of that type or two. And that's if you're really a kind of a careful perfectionist with really good handwriting and really organized work. You're going to make 3 or 4 of those mistakes if you're not.
So when is the test? Is it next
Monday.
Monday? Okay.
And I'll set it up so you have 2 hours plus like 15 minutes to fart around with scanning it back to me and so forth.
So when we're finding the surface area of something and we're going to be using an arc length, is it okay to calculate the arc length and then multiply that times your x in some range, taking the integral of that?
Yeah. So it'll always be the arc length times 2 pi r, 2 times pi times the radius, just like shells will give you the circumference of that thing, and then you're multiplying by that arc length, which is at an angle in the case of shapes that are curved.
Okay, because on the surface area section for number 5, I ended up with 842 pi, which seems really high. And I'm not sure if it's supposed to be like that.
Sounds massive, I agree. So that's E, I assume.
Yeah.
Let me reshare screen. So again, for me, it's all about drawing pictures. So what I'm seeing is, okay, the surface area of the region rotated around the x-axis. So that means I'm taking a little slice right here, a little ribbon, and I'm sending that around. But what I'm interested in is not the volume of that shape. Come on, man. I'm interested in the surface area of that shape. So I want that area right there. So I see now that its radius is a y value. There's its radius. So I need the arc length of that times 2 pi r. So I'm thinking 2 times pi times radius times that arc length, which we said was 1 plus either derivative. So you have two choices here. You could either say, well, hey, look, there's a y there, so I'd like this to be dy. And if that's the case, then I need this to be dx dy, the derivative of x with respect to y, so that I get y values there. Hey, look, everything is y values. What are my y values? They're from 4 to 1. Or you could say, no, I don't like derivatives that look like that. I don't like dx dy, I like dy dx. So I want this to be normal. I want a normal derivative, the derivatives I'm used to with y as a function of x. Fine, can you do that? Sure, just replace that y with what y is. What's y? 8 over x. Now we're working with x's. Where does this thing live with respect to x? From 2 to 8. Those are going to give the same exact answer. Did you do that? What did you do wrong?
I used x as the radius, and I didn't replace it with the 8 over x or anything. I just plugged in x times my arc length, so that's what happened.
Got it.
Hey, Doug,
Yeah.
for graphs that are based in y, like x equals y squared, blah, 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 how do you tell which parabola is on top?
Yeah, that's a great.
Because you know, for like x, you can see which one's on top, so you know which one to subtract from. But I feel like for y, I don't really know which one's on top.
Yeah, the problem is it's not so much top. It's like when it's vertical, top is top, bottom is bottom, and it makes sense. But when you turn it sideways, it's not so much top and bottom, it's right and left, which
Yeah.
that's why I keep saying outer and inner. It's like the furthest one away. That's why I have to draw a picture. I have to draw the little shape in there, the little slice that I'm gonna spin or whatever I'm gonna do with it, because I gotta see that and go, oh look, the outer one. So it's always kind of like and vertically it's the y max minus the y minimum. Horizontally, it's the x max minus the x minimum.
Okay, thank you.
But again, the cool thing is you get it backwards, so you get the right answer.
On number 4 for part A, can we look at finding the area of that region real quick, just getting that set up? Because I'm pretty sure, it's just taking the integral of one minus the other, but I'm not entirely certain.
Yes, we can. You said 4A, right?
Yeah.
So find the area of that region. This is a good example of exactly what Eve just said, which is, how do I do this? Does it make sense? You don't want to slice it like this. Why don't you want to slice it like that?
Because you're not given the points of integration readily. I mean, you could find them, but since they're already given to you, it'd be easier to just use the ones that are there, right?
Well, it's worse than that, because that height right there is y minus y. So notice that's top of orange parabola and then bottom of orange parabola. Whereas what happens to that height when you're here? Now it's top of orange parabola minus purple parabola. And now you're over here, and then it's purple minus purple. Does that make sense? So it's not
Yeah, that-
always the same graph that is outside minus the same graph that's inside. So that's a good example of one that doesn't work well unless you turn it sideways. If I turn it sideways and I let my rectangles do this, does it make sense? That height right there is x of the purple. This is x of the orange. So now I can say that height is x purple minus x orange. And no matter where I slide it, that's true every time. Do you see what I'm saying?
that makes total sense.
So then I say, okay, cool. What's the area of a rectangle? Well, it's the height, which is x minus x, and then notice that's a little bit of y. So then I just have to multiply those together. X purple minus x orange times dy. Notice I'm not having to spin it or turn it into a volume or anything. It's just like the area of that rectangle, and I'm finished. So as always happens, dang, I got x's and y's, and so now I have to, well, replace these with y's. So what problem do I run into there?
You need to know which one. Well, you need to put it all in your y values. You need to substitute your equations in, right?
Yeah, notice when you look up here, whoo, thank God those parabolas were given as already solved for x. You understand that? Because I would not have been able to resolve this. If those had said y equals with a bunch of x squareds in them, I would not have been able to solve for x, but they're already solved for x. And again, it's not, you're not as good at this sideways, but it's almost hard to tell which one is which. But again, everything is kind of turned right. This one is going to have a positive a value because it's open to the right, kind of going in the positive direction. This one's going to have a negative a value. So this one right here then is the orange one. But again, you don't have to know that. You can get out Desmos and type one of them in and be like, oh, okay, now I got it. This one is the purple one. So then I'm just going to replace those and say, okay, cool. So x purple, that's the negative 1/2 y squared plus 4y minus 4. Subtracting everything just to make sure it gets distributed. The negative sign gets distributed minus the purple one, which is 1/2 y squared minus 7/2 y plus 7 dy. And now I know I'm working with y's, and I say, oh, look, y is 5.5, y is 2. Like that's my limits of integration because I'm letting y do its sliding. What's your thoughts on that, Cheyenne?
Yeah, that definitely makes sense. I think I was just having trouble bringing it up from a couple weeks ago when we were doing that kind of stuff.
Yeah. Yeah, and that's what I'm saying. It's a big ask.
Can I ask about how you know that whether to use the Y or the X boundaries? Because that's really confusing me.
Yeah. For me, that's entirely based on what happens right here. If that's dx, then it's x's. If that's dy, then it's y's. So
Well, that's what I did for the quiz, but then you put notes on it saying that I used the wrong boundaries. So like I used x's for dx.
mind if we look at this together?
Okay. Like on the last question.
Yeah, see right here? You said dx, right?
Yeah.
So what are the x values for that graph right there?
Oh, I see.
You see what I mean?
Yeah.
You gave me y values, like you had determined there that it was dx, but then you put y values down here. You said from 0 to 2, not 0 to 4. So you gave me y values. That's why it didn't work.
Okay. Got it. Thank you.
Great question. And there was like 2 or 3 of you whose quizzes I didn't grade and I just graded them. Dominic, I see you in class. You sent your quiz to me, but it's like in some weird format. It wouldn't open.
Yeah, I think I know the reason behind that. I didn't like
Confirm.
authorize the download or something.
Just
Anyway,
resend it to me as an email now.
okay.
Actually, that's not true. I'm almost done with yours, Cheyenne. I was looking at it right now.
Yeah, I was about to ask, like, why is it still 0?
I thought you just said, I thought I was done with yours, but man, I want you to touch the screen, Cheyenne, and give me your artistic skill, your shape rotation. Like you can shade. I can't shade. I don't get shading.
Yeah, I've been drawing for a long time. So, yeah, I haven't had much time to do a lot of art while I'm in school. So when I see the tests, I kind of want to doodle on them and
Yeah. I enjoy that kind of stuff. Any of you guys that write, I don't know, little comments on things, I always enjoy that. I see all that stuff. You're like, you drew an easy button on 6.53. This is easy. That's awesome.
I was gonna color it in red, but I thought that might be bad practice since you grade the tests in red. So
No, I always try to be a human being with you guys and, joke around and all that. I appreciate when you do the same thing back. I see this as a very, especially calculus, because it's such a neat subject. You can tell you're learning things here that not very many people walking the planet understand, and it's kind of a neat journey. And I like the humanity of all of this. And I like when you add little notes. Like sometimes the project, I'm very aware projects are like, hey, if you wouldn't have given us this, I'd have a good life right now. So seeing personal comments like, this was really hard, but cool, what a cool problem, that kind of a thing. Or even I don't mind negative comments either, by the way. It's like, you're killing me here, Smalls, that kind of stuff. Your quiz is perfection, Cheyenne. since we happen to be here. I think I've asked you guys this before, but like I'm entering a score for Cheyenne's quiz. Do you guys get a notification of that? Or does it just, you don't? Were you checking, Cheyenne? Is that how you knew you didn't have a score, or did you guys get a notification?
Yeah, I don't get a notification, so I'll just, if I know I have something to be graded, I'll just check in throughout the day.
Check in every now and then,
Yeah, I usually leave the page up and then I just refresh it.
yeah. Mhm.
Yeah, I do that with a lot of stuff. So sometimes I'll have just a bunch of tabs open in my browser and they're just stuff from days ago that I'm done with.
Oh, yeah, I don't even want to talk about that.
You guys
Once
have messy rooms. You have messy rooms, don't you?
yeah.
Can't put your stuff away.
Thought it was kind of weird on the test how the questions 1A, 2B had like the same math answers, but they were like totally different equations. That
Yeah,
was just a weird thing that happened.
yeah, that is totally random and totally true.
Yeah, fortunately, my computer has enough RAM to where it doesn't really matter. So it's like I can have a bunch of stuff and programs open and it still performs great. So
Yeah, I haven't had a problem with my computer slowing down because of that. It's just a laptop, so I do shut it down. And then when I start it up again, I'll hit restore previous session on Firefox, and then I'm just hit with boom, a bunch of tabs opening.
I actually noticed that, Cheyenne, because I've Zoomed with you a couple of times outside of class when you had questions, and I remember seeing across there was like 13 or 15 tabs. Like, wow, that's a
Yeah.
right there.
Yeah, that's why, like when I type, I don't want the
Yeah.
camera on because some genius put the laptop camera at the bottom of the screen. So you kind of have to watch out how you angle it. Otherwise, the camera is looking up my nose, and that's not very flattering. And when I type, all you see is my knuckles. So
That's funny.
I use Opera and for a browser, and so like every time I close it, when I reopen it, it just opens up all my tabs that I had before.
That's interesting.
It's a Chromium based browser, so it works great with like Blackboard and stuff like that. But it's not Chrome at the same time, which is nice. Because I hate Chrome.
yeah, I was gonna ask. Like, I've used Chromium before a while ago when I was running Linux, and I don't really remember what its major differences were between it and Chrome. So I do have Google on my laptop, but it'd be nice to not have to open Google Chrome when I need to get into something Chrome specific.
I'm not sure what the exact difference is, but what I can say is, I mean, I've been using Opera for years, and I used to be an avid Firefox person until Firefox was just like, I don't know, it started getting really bad in like 2010-ish. And so around then I switched over to Opera and I haven't really used much else since. And it works nice because you can actually add Chrome extensions and stuff like that to Opera without having to use actually Google Chrome.
Nice. Oh, I did put a question in there about.
And I also just like the layout better. It's got a little sidebar. It's neat.
Yeah, I think the only time I've ever seen opera myself was when I had a Nintendo DSi. I think that was the browser or something.
Well, try it out, see what you think.
If no one has any questions about the review, I was wondering, Doug, if you had any more pointers on that pizza problem from yesterday. And I can wait until after class because I know that this isn't really relevant to what we're doing now.
No, yeah, let's talk about that a little bit, but anybody else has a question, just chime in and interrupt, because yeah, this is for review, so don't wait till we're done talking, but nobody said anything, so I got no problem with that. Do you know, Cheyenne, what the actual temperature is? Like, look it up on your phone really quick. What's the cooking for a normal pizza? Is it, I said yesterday, like 375 for 12 minutes, but I forgot. I was guessing. We might as well do it correct.
Papa Murphy's is 425 for like 12 to 18 minutes. I've cooked a lot of them.
12 to 18, so that's 15 minutes on average. So my hypothesis is that multiplying those puts, I guess, what I would call 6,375 degree minutes of, I don't know what to call it, energy.
It's work.
Yeah, it's kind of work. It's work, it's energy, that's the same principle for moment. It's like a force times the distance. There's a lot of things that are like this, a ton of things in application. So then when you turn an oven on, it starts out at room temperature, right? So it's like, let's say it's 70 degrees inside your house, and then it's going to kind of, work its way up to 425. But the question is, how does it get there? Does it get to 425 in a sort of a parabola shape? Does it go up there linearly? Or does it actually get up there slowly and then level off? Do you understand that? Like we need an equation to figure out how it goes up there. I'm inclined to think, and I'm just guessing about this, that I'm inclined to think it's this one. But I actually don't know. Like I could see arguments for every one of those.
Yeah, I was gonna say, I think it would have to do with the type of heating element, really.
Yeah, it very well could, because it is heating up. Mine would be like the box. I mean, the metal box it's in is also cold, and so although the temperature comes in, it's got to heat the box up too. So I think it's going to increase kind of exponentially. Now, it does increase continuously, which makes me think the equation is one of those, an E problem. So if I'm right, I bet it's E because it's increasing continuously. On a practical sense, maybe we could get online and search, and maybe some nerd has figured it out. If you heat something up, how's that gonna work? But the funner thing to do would actually be to gather data, like set a timer, turn your oven on. You'd have to trust that the temperature that it's telling you is actually accurate, but it'd be interesting to plot some data. So let's say at time 0, it was temperature 70, but again, I'm not sure it's going to say that. It seems like when I turn mine on, it says 100 like immediately, which makes no sense. And also it kind of depends where the temperature sensor is. Is it right next to the heat source, or is it someplace else? I don't know, but theoretically you could say, okay, after 1 minute it was at 82 degrees, and after 2 minutes it was at 99 degrees. I mean, this is not even close to true, I don't think. This is like 130. and then it went up to 195, etc. And then you did regression to find the, again, I would predict it or guess it to be an exponential kind of growth sort of a situation. But again, plot the points. So that's kind of cool to think about. Maybe it isn't. Incidentally, I'm suddenly realizing I have a meat thermometer. So a meat thermometer in the oven is not going to break it, right? Because those are go-in ovens, right, for your turkey on Thanksgiving. So if I turned the light on and stuck the meat thermometer in there, that'd be a way better way to get the temperature, because I'm not sure that the readout on the oven is actually accurate.
Yeah, I was actually planning on baking a cake this weekend, and we do have a meat thermometer, so I might just do that because it'll be, easy to set up and do. I can just see if it stays at the 350 or whatever for the cake and then go from there.
As Justin pointed out yesterday, though, there's a big difference between putting 6,375 degree minutes of energy into something super quickly, because you could set the oven to 6,375 degrees and put it in there for 1 minute. All right. And that's not going to create the same pizza. You could put it in there for at 1 degree for 6,375 minutes, but that's not going to cook the pizza. You know what I'm saying? So this is not apples and apples. The honest takeaway from this probably is, because you're spending time with the pizza in the oven too cold, if you will, it's probably going to mean that number up there has to be adjusted somehow. It's certainly not going to hurt it because the pizza is going to begin heating up. But really the question is, how long does it take it to get to 425? In those 15 minutes that you would normally set there, it's at 425 the whole time. And so if it gets to 425 pretty quickly, like in the span of a couple of minutes, then this probably would work great. But we're sort of spending a lot more time with the pizza cooking at lower temperatures, if you will. And so the question is that going to screw it up in some way? Generally speaking, if you cook something too high, the outside burns and the inside is uncooked, right? If you go really slow, then the inside cooks more completely, if you will, and you don't kind of get the crustiness on the outside. And so I think this will work. I think this will work in the case of a pizza because it's not in there super long. But in the end, if you look at this graph, kind of this time and temperature graph, if it started at 70 degrees and it ramped up to whatever it got to, but again, it's not going to do that. It's actually going to ramp up to 425, and then it's going to level off. So it's like two different graphs. Does that make sense? Because it's just going to kind of shut off when it gets up there. And so what I need that area right there to be 4375. Notice I'm multiplying temperature times time in minutes, temperature in degrees, the area under that curve.
6375.
6375. Yeah, I just realized that too. So that is going to have to be done in two different sections. So this I'll just use. I won't use calculus for that section. I'll just multiply the rectangle and get the area myself. But I'm going to need calculus for this section. So I think a pizza is a good guinea pig here because it's probably still going to be okay. If I spend all this time baking a cake, Cheyenne, if this doesn't work because it's cooked too low and slow, I'd be a little more mad about that because I spent a lot more time at it.
Yeah, I was gonna say also when the temperature is lower, it's almost like you're proofing the dough like they do with like bread, I would think, where it's like whatever yeast in there is like expanding, so it's gonna make your crust even like different. It just depends on the type of dough that's being used in the crust too. because like when we cooked bread at Subway back in the day, we'd have to put the dough into a humidifier thing that was at like 120 degrees until the dough expanded into a bread shape, and then bake it at a certain temperature for a little bit.
Yeah. Is anybody else envious that Tiana gets to do her math in a queen's throne?
My mom likes to decorate. It wasn't my idea.
Well, that's awesome. She loves you. It's the definition of being a queen. You didn't do it for yourself. You have people for that. Right?
I'm the only girl. I have 3 brothers, so I get spoiled sometimes.
Oh, that's fair. You seem like a hard worker, so you deserve to be spoiled from what I've seen.
Hey Doug, can I ask a question about the project?
Absolutely.
So I sent you an email last night. I was gonna do it over Zoom, but I'm like, I can just send this in an email. So I sent an email about the surface area, and I can't see anything wrong with my surface area, but I'm thinking we took the surface area of different things. So I sent you an email that shows you the project so you can open it up, because
Cool.
I'm currently not on Zoom on my computer.
Okay. Yeah, I'm going that direction right now. By the way, just while I'm thinking about it, occasionally some of you will send me like, the window closes and then you're like, oh, I made a mistake. And then you send it to me, which is all great. I love that you do that. Just make sure that I follow up on it. Cause I mean, a lot of times I'm grading inside my open math and, then there's an email over there and I usually get through the emails and catch that stuff and fix it eventually, but just don't let me off the hook there. I have no problem with you guys doing that. I think it's great. All right, no, that was the quiz. I got your email. I got the email and you sent me quiz 3. When did you send that to me? I don't have anything from last night. Eve?
You don't?
Mm-mm.
That's not the email I'm talking about. Hold on, I'll send you a new email.
Was it in messages, not email?
No, it was an email, I'm pretty sure. Here, I'll just send you another one. It's fine. I can just re-download it. Is this project 4? Yeah.
Yes. Maybe it went to junk for some reason. Occasionally things go to junk for no real obvious reason.
Apparently I have a lot of project 4s. All right, it should have sent.
Cool. No, I don't see it in junk, so something went wrong in the universe.
You don't see it?
Nomum.
Huh. Let me try sending you a message in my open math.
Wonder what's going on there.
Okay, I just sent you a message in my open math.
in my open math. I am
Yep.
refreshing my screen. There it is. Got it. Let's see, do you know your answers are right or wrong? I forgot if you checked those with me.
I checked my volume answer with you, and that was right. And I checked my surface area answer with you, but that was wrong. And I'm thinking that because I can't see anything wrong with my surface area,
Mhm,
that we're just taking the surface area of different things.
Sure. Okay, so looking at my sheet, you said squared. Got it. So you solved for x. So that's different than what I did, which is of course fine. So you have 1 minus 4, so 4, it's on the bottom, so that'd be right. So I don't see anything wrong with that. Oh, that's right. Yeah, you said something about the torus and so forth. So partial derivatives. How in the world do you know all this stuff? Jacobians and how the heck do you know that? Eve?
So for projects, I like to, I'm not saying your projects are easy because they're definitely not easy, but I like to have fun with projects, you know,
Yeah.
try and like explore all options.
Yeah.
So I have a different project that kind of shows the solution in the way with the crazy, ugly derivative, you know.
Mhm.
But in the textbook, at least my version of the textbook, because I have a different one than you, it mentioned Jacobians, and I thought, you know, why not? You know,
Yeah, we're gonna get into
took a
this.
lot of Khan Academy videos though.
Yeah, that's amazing. I'm just so impressed with you. Yeah, we're going to talk about this formally, I think, in 253, if you're staying through that. I taught through that Calc 3 and 4 last year for the first time. And so,
How'd that go for you?
yeah, so so actually I know it poorly enough that I'm going to have to stare at this a bit to get it back, if you will.
I think I got it right.
So let's see. So basically what you did is you took a little time out and said, let's figure out the surface area of a torus. Is that what you did?
Yeah.
And you found the formula 4 pi squared AB according to that. Did you check that online, like Google search, and you know, is that like the surface area? Does it work? Is that true? Just making sure I understand what you wrote.
Yep. That's true.
Sweet. So you're right, that absolutely would work. So the only
Did you just take your equation and do the surface area using the integral of 2 pi rx?
Yeah.
Okay.
I just did it
Because that makes more sense.
That's the easier way to do it. But the fact that you notice that's a chunk of a torus is really cool. So the only problem is, like, you know, we're not using the entire torus. We're using the bottom half of it. Does that make sense?
Yeah.
But it's the outer bottom half of it. So unfortunately, that 4 pi squared AB, you're not going to be able just to say, oh, it's a fourth of that. Do you understand that?
Oh yeah. Yeah, okay.
So you
Yeah, I
still,
see
if
what
you're
you're
going
saying.
down that road, you still got work to do. You got to think, oh no, what portion of that do I need? And it's not a fourth. So I could take half, that's clear, because like the top half is not there of the donut or torus. And so, okay, great, I'll take half of it, awesome. But now I got this bottom portion and I really need the outer part, the outer half of that bottom portion. And off the top of my head, I'm thinking, gee, I don't know how to do that. And I'm a little worried that it would be like, in order to get that, you're going to have to do, well, the easy version of this project, or maybe go back to the formula that you set up involving the partial derivative and so forth, and change your limits of integration or something.
Okay, I'll take a look.
Yeah, good question.
So the volume still works though, right? My total method isn't confusing.
No, not at all. It's totally cool.
Okay,
Love it.
cool. Thank you.
Actually, let me check the 3 is your volume solution, right?
3 is the solution for both, but there's a V in front of volume.
Oh, there we go. Yeah, I can see it. V and A, got it. Totally clear. I'm not sure. I don't remember ever. Did you change that into a decimal, or did I ever change that into a decimal? Because I don't have the answer written the way you do, so I just can't remember off the top of my head.
Yeah, I did change it into decimal. It was like 6 point something. I don't quite remember. I mean, not 6 point
Yeah.
something, 100 and
So yeah,
I think
yeah,
it was close
we
to
did.
150.
Yeah, that's right. Whoa, you actually got the same. Oh no, that's area. 66 plus 28 pi. That was such an interesting answer. 66 plus 28 pi times pi. Yeah, that's right. So yeah, that's a hair too big. What did you do? Did you use that 4 pi squared AB and then cut it in half? Like, what did you do to get 66 plus 28 pi times pi?
I just simplified down the equation. So like I multiplied 2 times 4 and I times that by 2, the 2 pi, except I left the pi alone. And then I kind of did that for all of them and joined them together. And then when I got to the final 68 plus 28 pi, I kind of just simplified out the pi squared. So it's just because those were all times pi and that was pi squared. So I just pulled out the pi. I suppose I could have left it alone, but
Well, let's see, there's something wrong there. Actually, I think your simplification is wrong because you really went back. If I'm looking at your step number 11, you went back and did that not using the Jacobian or whatever. You just kind of did it back based on the way you had the original problem set up, sort of in the way we were teaching it in class, the simple way. But if I just look at those, no wait, there is a pi squared there. Never mind.
here, I'll check my simplification real quick.
Plus 3 minus 2, that's the top, plus a quarter. So the only thing that's
I'll see you on Tuesday. Thank you.
okay. See you Tuesday. Oh, it is 9:41. I didn't realize that. This has been over for 20 minutes. I love this stuff. I never even noticed what time it is. So yeah, your circles and inner cylinder are all correct, which aren't calculus, and so then all that remains is really that 1/4 4 pi squared thing that we have. So I'm gonna. So you did yours in terms of x. So I'm gonna kind of do what you did and see what I get.
I might just have to do my original, I suppose, actual calculus version of the project, because if the surface area is still wrong, I can't see a way I would have to take the surface area except for using the original equation to do the derivative.
Yeah, I mean the reason it's wrong is because yeah, I see now you took your Jacobian and you just said, oh, it's 1/4 of that because it's the bottom half and then it's half of the bottom half, and so you said it's 1/4 of your Jacobian formula, so that's why it didn't work.
Because
So
it's not 1/4, it's 1/4 of the bottom half complicated thing.
yeah.
All right, well, I'll take a look at, what were you gonna say?
The question really is it, I mean, it's clearly in the bottom half, so you could take half, see Justin, you could take half of the donut or torus, like take the top half and throw it away. And now you look at the bottom half and you say, okay, I'm interested in the outer area. So maybe you get lucky and it's not half, but maybe it's 2/3. You see what I'm saying? Maybe it's
Yeah, but it's hard to just like guess the fraction of it that it is in comparison of just taking the ugly derivative surface area.
Mhm. That's absolutely true. You'd have to create, I don't know, like a proof or find using calculus, find the outer area and then find the inner area and see if they're related. They could be not related at all, but it could be that it's 1/3 and 2/3. We see that a lot with circles. There's this volume is like that, like in the cone, it's like 1/3 pi r squared h, so there's like 1/3 and 2/3. If it actually came out that it was 2/3, that would not surprise me.
All right, I'll look into it. I'll see you Tuesday, right? Because Monday's test day.
Yep. All right, see you then.
Yep.
Fire away.
Have a good one.
See you later. Anybody else have questions?
Yeah, can I check what my answers for the project?
Absolutely, go ahead.
So for the volume, I got 146.830,
Correct.
and the surface area 383.1602.
Correct again. You are.
Cool. Okay. Thank you.
By
See
the
you
way,
Tuesday.
by the way, Gabriella, I made your test go from 1 to 3:15 because I was thinking 5 minutes is maybe not enough.
Okay.
So you have 15 minutes or a total of 2 hours and 15 minutes. Just FYI.
Okay. Okay. Thank you.
Yeah, good luck. Wisdom teeth, how many are you getting out?
All four.
Okay, cool, bam. And
Yeah.
was that in the morning?
The tomorrow morning.
Oh, tomorrow morning. Okay, so you'll probably be functional by then. I was making
Yeah,
sure
hopefully.
it's Day and you might not be in good shape to think. So
Yeah.
okay.
Okay. Thank you.
Yeah.
I had a question about setting up the project.
Mhm.
So, using shells, since it's going around the y-axis, what we talked about earlier, I would use the template of 2 pi x times y1 minus y2.
That's right.
So when I set that up, I start with 2 pi x times my circle equation plus 2, because, oh, let me just share my screen. So this is my circle equation, and then I solve it for y. And then when I do this minus 2, which I think is my, wait, that's not my y2. I think I see the problem. But anyway, I started out with this minus 2, so I would end up with this, which is just plus 2, and then I had that multiplied by x, and then I do this to it, and it's undefined. But I think I know what the problem is because this is an x, not a y, right?
Let's see. I'm just about in agreement with you here. So what's the plus 2? Like, how come the
I was doing y1 minus y2, so I thought that my circle would be y1 and that the 2 was y2, but this is an x, not a y.
good job? That's right. So what's your y2? And
I'm not sure now.
so
Would
from
it-
that black curve, how far do you go down? You go down to what for the bottom of your
0, right?
0? That's right. In this case,
Okay.
there isn't a second equation, so it's really y minus nothing. It's just y. Like the y coordinate of that black curve is your y value. That is your height. So you're not subtracting anything.
So I must have something else wrong then.
Well, and yeah, your 4 is there. So now think, where does that live? For what X values does that exist?
I think it's 2 to 7, right?
No. Does the circle exist at X is 2?
That's right. Oh, I was wondering about that last night because I know that it's not defined past 3.
Yeah,
And then I wondered if I could find the volume of this shape and then add it to the volume of this shape.
right. And you don't have a choice in this case because you're right. I see why you said 7 to 2 because you basically said this thing exists from X is 7 to X is 2. But unfortunately, the circle doesn't go all the way over to X is 2. So you can't say I want the area under a circle if there's no circle over there. So you have no choice but only to go from 7 to 3. And then you're going to have to think, because you're on a totally different equation now, you're going to have to think
Yeah.
differently about what's happening from 2 to 3.
Yeah. Yeah, and I remember realizing that last night and wondering why after wondering. Okay. So once I know that, it should be a lot simpler. Okay. I'll see you on Tuesday. Does the test open at 8?
Yep, 8 to
Okay.
10:15.
Thank you.
Yep, have a good day.